Alright, here we go. Let's, section 1-4, we're going to talk about angles today. Alright, so write that at the top. Alright, going to talk about angles. Well, angles are actually a combination of something that we've talked about already. Well, not exactly a line. Let's do this. What if I did that? What's that thing right there called? It's got an arrow on the end, so it's not a segment. It's a ray. That's right. Okay, it starts right here, and it keeps on going forever in that direction. All right, so that's a ray. It's not a line segment. A line segment would have an endpoint right here. It's not a line. Why is it not a line? That's right, because you would need to have an arrow on this side right here to be a line. Everybody with me on that? Okay, so that thing's a ray. And let's draw another thing. Let's draw something about like that. What's that thing I just drew? That second one. That's another ray. But guess what? It's not just any arbitrary ray. Where did it hit? The endpoint of this ray is where?
Same endpoint.
Same endpoint as this ray right here. Do you see that? So it's two rays that share the same endpoint. You follow me? So it's two rays. They share the same endpoint. It's not like they just intersect anywhere. They have to intersect at the endpoints. If they intersect at the endpoints, guess what we have? What is this whole thing? It's an angle. That's right. All right. So we'll write it again. So the whole thing is an angle. Now let's talk about how to describe the angle, because we did that with lines, we did it with planes, we did it with points, we did it with line segments. So far, only a week in, we've already talked about a lot of ways to label these different things. Well, let's talk about an angle. Now, let's call this B right here, and let's call this A. This ray that I've labeled right here, what would you call that as far as the ray is concerned? Rachel, what would that be? This ray right here, how would I name that? If I said, okay, name that ray, what would you say the name of that ray is? BA. You'd start at B, right? You start at the end point, and you keep on going through A. So that would be ray BA. All right? Trevor, what would this bottom ray be called? BC, right? Ray BC is what we would say. Ray BC. The combination of those two rays makes up an angle, and the way we call what we call this angle is this. Oh, by the way, I forgot a word. This endpoint that they both share has a special name. Okay, that's a pretty important thing right there, and it's called a vertex. Yep, it's called a vertex. All right, that's a really important word. We'll use that word a lot. Pretty much all through the year, we'll use that word right there. All right, so that's the vertex. Now let's talk about this. And the vertex is a point. So if I said, what is the vertex of this angle? You would say point B. All right, so vertex is a point. If I wanted to name the angle, we always name it having the vertex right in the middle. Right? And it doesn't matter what order as long as the vertex is in the middle. So Travis, say it.
ABC.
ABC. Angle ABC. And I can name it any way I want to. All right, Emily, what would I name it if I didn't want to name it ABC? What's another way I could name it? CBA. All right, so I could name it either way. And this is the little symbol we do. All right, kind of looks like a L, little slanted L, but it's an angle symbol. Okay, that's the symbol we use for angle. Anytime we write an angle, we put this little symbol right here. So I could call this thing ray ABC. Or, what else could I call it? CBA. Now there's actually something else I could call this angle. If I wanted to, if there's only one angle coming out of that vertex right there, I could just use the letter of the vertex and nothing else if I wanted to. So if I could just use the letter of the vertex, what's another possibility? I could name it angle what? Angle B. That would be a nice easy way to name it, wouldn't it? All right, just angle B. But if there was another angle coming out of this, I couldn't just name it angle B. I'll show you that in a second, all right? Here's another way, and it's kind of a nice way sometimes. I haven't drawn it on here, but what if I put like a 1 right there? And it's in between these two rays? I could also call it angle 1, right? If you had that number in there. Sometimes they don't have a number in there, sometimes they do. Sometimes they don't have any letters, and they only have numbers in there. All right, it just depends. Sometimes they'll have both. They'll have letters and numbers. Sometimes they'll just have letters. So it just depends on the situation. But you see all the different options that you can call that one little simple angle. All right, and if they ask you a question about it, you need to name it. Any of these things right here, put the or in there. Any of these things would be right. We okay with that? Pretty simple. Let's do what I was going to do a little earlier. What if I did that? And we'll call this point D. All right, now, could I call this angle 1? Could I call it just angle B?
No.
No, because I don't know what angle I'm talking about. Because look, there's other angles coming out of angle B. How many angles have B as a vertex?
2.
There's 3 actually, right. There's this angle 1. Let's call this angle 2. Where's the third one?
The whole thing.
The whole thing, right. You could talk about that whole thing. If I wanted to call it angle 3, I could. Do you see that? So let's think of the different names that I could call the angles. So angle 1, we already talked about that. What could I call angle 1? What's another thing I could call angle 1? We've already talked about it. It's even written up there. ABC, angle ABC. What about angle 2? What else could I call angle 2? CBD. Or I could go DBC. I'm not going to give every single option, but we'll go CBD. That's angle 2. What about angle 3? What could I call angle 3?
Angle 3.
A. I could call it angle 3, but what's another name I could call angle 3? A, B, D. Do you see that? Or I could go the other way. Could I call it ADB? It's got the same letters. No, because what has to be true? The vertex has to be where?
In the middle.
In the middle. Oops, that's not exactly. There we go. There we go. The vertex has to be in the middle if you're going to use 3 points like that. Does that make sense? All right, that's pretty important. We're going to be doing this pretty much all year, not just on this chapter, but almost every single chapter. We're going to talk about angles, and we're going to need to name the angles and be able to tell what angle is what. And it's very, very important. I mean, this is probably one of the most important beginning topics that we're going to discuss because we're going to really use this throughout the whole entire year. Everybody with me? All right. You guys aren't messing with her, are you? Okay. All right. So let's see. Let's talk about this too. We talked about this being a vertex. What about this ray itself, like ray BD or ray BC or ray BA? We have another name for that as well, and we call those the sides of the angle. So the rays themselves are called the sides of the angle. All right, so the end point is the vertex, and the ray itself is the side. So there you go. I'm not going to label every one of these, but all the rays would be considered a side of the angle. All right, let's do this. Let's go to a different color here. Let's go to red. What if we had a point and it's right there? Is that point on the angle? No, if we talked about a point being on the angle itself, it would have to lie right on the side or right on the ray. Everybody with me on that? Or it could lie at the vertex also. But if this is here, consider angle ABC or angle 1. Everybody see that? Angle ABC? What is this red point in relationship to this angle ABC? It's not on it. What do you think? It's in it. That's right. We say it's in it. If it's in between the two rays, we say it's inside the angle, or it's in the angle, or it's in the interior. That's the word that they use. It's interior.
Why do we care about that one?
Because there's going to be some definitions and there's going to be some theorems and stuff that talk about points in the interior and the exterior and all that kind of stuff. Okay, so it will make a difference at some point. Right now, we're just learning, the names for them, that's all. But there will be a time when you do worry about points being inside the angle or on the exterior of the angle, okay? Of course, I just gave it away. What if we had this? Talking about ABC, this would be on the exterior. Good. This would be the exterior of the angle. It's just all vocabulary right now. We're just trying to learn a new language. Geometry basically has its own kind of language, and that's what we're doing. Okay, we're learning all these different names because we're going to use them eventually. All right. Okay. Let's do this. We can also measure angles, and you've probably talked about this kind of stuff before. If I had an angle right here and let's see, right there. Okay, so there's the two rays that makes up that angle. Well, they're supposed to pretend they hit right there, okay? And we can measure this angle. Now, what do we use to measure? Do we use inches? Do we use feet? Do we use meters? What do we use to measure degrees? That's right, we use degrees to measure the angle. All right, yeah, and you could use a protractor to use that, and I'll show you something here just in a second. All right, so we use degrees to measure the angle. All right. Let's see what else before we talk protractor. I tell you what. Let's move on. Let's let's do a couple other things. And the very last thing we do today, hopefully I'll have time for this, I'll show you something about the protractor, okay? So, okay, I've drawn 3 different angles right here. I've drawn this one right here. Now, I heard somebody whisper it when I was drawing it earlier. What do you think this kind of angle is right here? You'd think it was, but you're making a pretty big assumption right there.
90 degrees.
You're making an assumption that's exactly not. How do you know it's not 91? How do you know it's not 89? How do you know it's not 89.999? That's right, and you don't know, do you? That's the answer, right? You don't know until, and you guys said it, you put that little, oops, that was ugly. Let's try that. That's a little bit better. Okay, you put a little box right there. All right, you put a little box right there. That means that that's 90 degrees. All right, again, we measure this in degrees, and you kind of know what 90 degrees is. We'll talk about that when we stick the protractor up here in a little bit. All right, so that's 90 degrees. You know what a 90-degree angle is, don't you? Have you heard that before? It's a right angle. All right, so a right angle is equal to 90 degrees. What about this angle right here? Do you think this is bigger than 90 or less than 90? Less than 90, right, because 90 would go straight up and down like this, wouldn't it? And this gets closer and closer to this other ray, so this would be less than 90 degrees. And we call this, what do you think? We call it an acute angle. All right, an acute angle, which would be what? Less than 90 degrees. It is. And the one that's larger than 90 degrees, because watch, 90 degrees would go straight up like this, wouldn't it? But this keeps going more, it gets bigger and bigger, so we call that obtuse. That's an obtuse angle, and it's greater than. Technically, that's not really what it is, but as far as it's actually between 90 and 180, but I just say greater than 90. It just kind of makes sense, and it's just easier to remember that way. All right, so it's greater than 90 degrees. Technically, it's between 90 and 180. All right, and this is technically between 0 and 90, but I just say this. We good with that? Now, here's another one that you may not have thought of. Watch this one. Okay, that's a ray right there. It's got an endpoint right there. But watch this. This is also an angle. Some people don't think it's an angle, but it actually is. What kind of angle is that?
180.
That's right. And it is an angle, right? Because it's 2 rays and they share a common endpoint, don't they? So must be an angle, and that is 180 degrees. From here to here. All right. See, I use these little arcs to indicate, you know, the degree of the measure right here. It's 180 degrees. Now, we call this right, acute, obtuse. This is one a lot of people don't remember or don't think about, but we call this a straight. Good. Kind of makes sense, doesn't it? All right, it's a straight line, so we call that a straight angle. Everybody with me? So straight angle is exactly 180 degrees. Pretty simple. Yes, I do. Let's see what else we got. Okay, we're almost there. Let's see what I'm gonna. Let's see what I'm gonna do now.
180 would be obtuse, wouldn't it?
Yeah. Let's. What am I trying to do? I'm trying to do this. Watch this. Yeah, you can go. You can go. Well, we'll talk about that. I don't want to talk about that right now because we'll get into that at some other point. Watch this. What if I had an angle like this? Everybody watching? You guys? Alright, I'll group that. Now watch what I'm going to do. I'm actually going to use my little program here. I'm going to copy, I'm going to paste. So, guess what's true about this angle and this angle right here? Alright, they're exactly the same. Alright, so whatever that angle was, and I don't know what the measure of that angle is, but I do know, since I copied and pasted it, they have the exact same measure, don't they? Alright, so we say that they are, say it, Chandler, you said it, I think. We say they're congruent. So they're congruent angles. If they have the same measure, if the measure of the angles are the same, we call them congruent. Here's the symbol for congruent. It's an equal sign with a little squiggly over top of it. Okay? So it's an equal sign with a little squiggle over top. That means congruent to each other. Alright, I'm running out of time. I better stop now.